Hello children, you're welcome to this segment of the program The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I believe you enjoyed yourself revising a lot of the topics that we have taught before during our revision session last week. This week we are moving on to something familiar but something quite new at the same time. I believe you are going to enjoy yourself. This week we'll be talking about lines and angles. Now we have talked about angles before, but we'll approach angles from another angle. All right, let's see what our objectives for today are. By the end of this lesson, you should be able to identify and differentiate between horizontal and vertical lines. I mean, there are a lot of kids out there who do not know which one is vertical, which one is horizontal. They mix it up. But I have a short video for you that will clarify that. You should also be able to recognize lines that are parallel and those that are not parallel. And you should also be able to recognize what we call perpendicular lines. I'm sure some of you are saying, what? Perpendicular. You will see what that's all about very soon. Finally, you should be able to identify angles that are, we call them vertically opposite. Do not worry yourself at this stage about what all these are. I will explain in details as we move on. So let's just get right into it. We'll begin talking about lines with points. What are points? I'm sure you've seen points before. In mathematics, you work with decimal points. Okay, your full stop in English is also a point. A point, we say, is the smallest geometrical object. And you have examples here. Here is one and here is another one. And you must be thinking, I can draw something smaller than this. Yes, well, even I can draw something a lot smaller than this. But, I mean, this is a point. And this is another point. But I'm sure that you can't see them because they are too small. I only make this one big because I want you to be able to see what I'm talking about. Now, a point, as I have said, is the smallest object. Okay? It has no length and it has no thickness. It is not long, it is not short, it is not wide, it's just a point. You can make a point with the tip of your pen or your pencil. Just hold it this way and you have a point. So let's say a point is usually denoted with a letter like A. So if you have a point, you can call this point A. You can call another one point B, another one point C. You can't have 2 points standing on top of each other. You know, they're always going to be separate. Okay. So a point can be represented by many things in real life. It could be your sitting position in your class. That's one point. It could be your position on the assembly line. That's another point. It could be the location of your house. That's another point. So you will agree with me that you can't have 2 houses on a particular spot. Okay. So you get generally what the idea of points are. Now we can talk about lines. What are lines? A line joins 2 points together, and I'm sure you've seen lines before. You probably are imagining it in your head right now. Oh, line. But any shape that you use to join 2 points together is what you call a line. Now you will see now that a line, the way I will define it, may be different from the way you understand it. Lines could be straight, you know, like this one here. You know, oh, this is a straight line. Yes. It could also be curved. You know, it could be like that, or it could be like that. Basically, what we call a line is when you have 2 points, say, like this a point, and like this a point. Anything that you draw from this end to the other end is a line. This is a line joining this point X and the point Y. That's a line. It's like the child that was sent from home to go and buy probably Maggie and decide to make a detour to this place and another one to this place. Or another one goes from here. He's supposed to go and buy Maggie, but he first goes to the place where they are watching wrestling by the roadside before going to buy Maggie. You know, that's what lines are. Any shape that you draw from one point to another is a line. Let's move on. Now, a straight line is a type of line. it connects 2 points together, but of all the lines that connect 2 points together, a straight line is the shortest one. Now, you have 2 points there. We can draw several lines to join these points together. Okay, this is one line joining the 2 points. This is another one joining the 2 points. This is another one joining the 2 points. But by the time you draw all possible lines, you will discover that the shortest of them will be the straight line. And that's why we say that a straight line is the shortest line that joins 2 points together. Now, straight lines could be what we call horizontal, they could be vertical, they could be diagonal. And these are keywords that you should put down in your notebooks. In the subsequent slides, I will be showing you how to differentiate between horizontal, vertical, and diagonal lines. So you just give me your 100% attention and you will see what that's all about. So what's horizontal lines will go from the left to the right, or from the right to the left. It's sort of gotten from the word horizon. I'm sure you've seen the horizon before, but you may not realize you're seeing the horizon. In the evening, when the sun is about to set, you look out towards the sunset and you see a line, and it seems as if the sun disappears over the, at the back of that line in the distance. That line that you see is what you call the horizon, and it is from the word horizon that we get horizontal. Okay, so whenever you want to remember horizontal, remember the horizon where the sun sets. You will see it in the video that I'm going to show you, and then you remember left to right, and you remember horizontal lines. Let's move on. So now let's watch this video. It's a song actually, so I want you to take your time, enjoy, but pick up the learning points, and Uncle Abadio will be back to go on with the lesson. So I believe that you enjoy the song. Lines all around you and me, you know. Watch it on YouTube and you'll learn the song. Let's talk about relationship between lines now. The first one I want to talk about is parallel lines. I mean, what are parallel lines? We say that two lines are parallel if they are always at equal distance from each other. Whichever way you look at it, the distance from here to here, if you move down the lines, the distance will still be the same. They're always the same, at the same distance from each other, no matter how long the lines are. Look at this. When that distance arrow moved down, it was still the same. So now parallel lines will never meet. It will continue like that. They will never meet at any point in time. So these are parallel lines. When they go in the same direction and the distance is always the same, they are parallel lines. So my friend, you want to note this word parallel, very important. Next one here says that in this diagram, the line AB, that is this one, this line here is parallel to the line CD. And so in your books, when you're reading and you come across this symbol, don't be confused. AB, and you see a line, that means a line connecting A and B. CD, it means a line connecting C and D. And you see this symbol between, like, you know, equality sign that has been rotated 90 degrees or something. This means parallel. So that means that AB is parallel to CD, in case you see it in your books. Moving on. Now parallel lines are everywhere around us. Like that song said, lines are all around you and me. So you find parallel lines on the piano, on the ladder. I'll show you the parallel lines here. These are parallel. You find it in the bookshelf. These are parallel. Also, these are parallel to these. So find them on the railway tracks. You find them in your notebooks. The lines are already drawn for you. You find them on the race tracks, you know, parallel lines. On, you know, power racks, on the bricks along your fence, you'll find parallel lines there. They are everywhere. In fact, if lines were not parallel, I mean, so many structures that we live in would have probably collapsed. And now moving on. Now, when lines are not parallel, it means they will meet at some point, because remember that parallel lines will not meet. But if lines are not parallel, then that means the distance between them will be changing. At some point they will meet, like these lines. See them go, see them go, see them go. They have not met, but if I extend the lines, you will see that eventually they will meet. See? Now they meet at this point. Okay, so these are what you call intersecting lines. They meet each other, which means they cross each other at some point. Now, usually lines meet at a point. For instance, this one, they meet at the point O. We have line AB and line CD meeting at the point O. We say they are intersecting at the point O. And whenever lines cross each other like that, guess what happens? Automatically you will see angles formed. This is an angle that has been formed as a result of the lines meeting. This is another angle, this is another angle, and this is another angle. Usually when two lines cross each other, 4 angles are formed. So let's move on. Lines A, B, and C, they have said they meet at the point O and they form the angles. This is angle AOD, angle AOD. We have AOC, COB, and DOB. You do not need to worry yourself about this naming right now, just to know that when lines cross each other, angles are formed. Now, let's talk about vertically opposite angles. When angles meet each other like this, and the angles are formed, you have what you call the vertically opposite angles. And these are angles that it seems like they want to cover each other. They are facing each other. For instance, this angle AOD is facing angle BOC. Then they are opposite each other, and we say that they are vertically opposite angles. Again, this one is facing this one, and that means that the two of them are vertically opposite each other. Now, vertically opposite angles are always equal. They have the same size. This angle is the same as this angle, and this angle is the same as this angle. But how do you recognize vertically opposite angles? You recognize them with the X shape. Anytime you see lines crossing each other, no matter how they are drawn, once you can draw the X, the angles that are facing each other are vertically opposite and they are equal. This one and this one are vertically opposite and they are equal. So you recognize them with the X. The X can be drawn anyhow. It can be like this, it can be like this, it can be long, it can be flat. You will always find vertically opposite angles when you see the X. Let's move on. Now, perpendicular lines. If the angle between two lines is 90 degrees, then we say that these lines are perpendicular, like the lines that I'm going to show you. You remember that when you have the box in the corner, it means 90 degrees. When the angle between the two lines is 90 degrees, then we say that the two lines are perpendicular lines. Say perpendicular lines, perpendicular lines. Good job. Now, in the diagram that you see here, the line AB is perpendicular to CD. And this is how we write that in mathematics. Whenever you see this symbol, it means that the two lines are perpendicular. The angle between them is a right angle. So we've talked about so many things today. We've talked about parallel lines, they don't meet. Intersecting lines, they form angles. Perpendicular lines, they form angles too, but the angle is 90 degrees. Let's move on quickly. So now perpendicular lines are everywhere around us. You find them on the window, you find them on the bridges, you find them on the electric poles. When the time is 3 o'clock, when the time is 9 o'clock, you find perpendicular lines. The angle is always 90 degrees. And let's look at some evaluation questions to test how well you have followed the lesson. This is a cuboid. You have to study it and answer the questions that follow. Now, which of the edges are vertical? You know, edges are the straight lines. Which of them are vertical? You should see them by now. The correct answer to that is AE is vertical here. BF is vertical, as this one is coming from up to down. DH is vertical, is coming from up to down, and CG is also vertical. All the lines that are coming from up to down are vertical. This one says which one is perpendicular to FG. Perpendicular, remember, meet at 90 degrees. So where is FG? Here is FG. So now BF will be parallel to perpendicular to it, 90 degrees. Also CG will be perpendicular to it. This one says which one is perpendicular to DH. Where is DH? Here is DH. So the ones that are perpendicular to it will be AD and EH, and there you have it. Now let's look at identifying vertically opposite angles. Don't forget that we can identify vertically opposite angles with the X. So now which angle is vertically opposite to G? Here is G, and the one on the other side will be C, and that's exactly the one that is vertically opposite to G. This one says which angle is vertically opposite to E? Here is E, but which one is vertically opposite? Is it H or B? If I draw the X, it's going to give me A. That A is exactly on the other side of E. So A is vertically opposite to E. This one says which angle is vertically opposite to B? Can you identify that from the diagram? Is it going to be G, F, or E? Well, the correct one should be F, because it's directly on the other side. I've told you that vertically opposite angles will look as if they want to close each other. Okay, so now for your assignment, I want you to capture this diagram. You're going to identify all the angles that are vertically opposite to each other. You will also tell me which lines are parallel to each other. You have 30 seconds to do that. Now we've come to the end of the mathematics segment of the program. I will now hand you over to Uncle Popo for the general studies lesson. Till I come your way tomorrow, remain wonderful mathematicians.